Good morning, everyone. Today we are going to see about unit 3. Okay. Unit 3 is feedback system in power amplifiers. Generally, in this unit, we are going to see about the feedback system. That is, this unit provides an understanding of feedback, entire feedback system in RF power amplifiers, which are the fundamental components in modern communications and electronic systems. First, we are going to study with the feedback system, that is including the stability of feedback system, that is a stability analysis, gain margin, phase margin, root locus techniques, and time and frequency domain consideration. These concepts helps engineers to design the system that operate reliably without oscillations and instability. Okay. Next, that is, we are going to see about the various compensation techniques are also discussed in order to improve the system, the overall system performance and stability. Then, in this unit, it also focuses on power amplifiers, which are used to increase the power of signal before the transmission. That is, the different classes of amplifiers, such as class A, class B, class AB, class C, class D, class E, and class M. You are already studied it in electronic circuits, right? And the secondary itself. So in this unit, we are going to study about different types of amplifier. That is class A, B, AB, C, D, E, and F. Or study with respect to the operation, efficiency, and applications. Since the RF power amplifiers introduce a non-linear distortion, that is, various linearization techniques and efficiency boosting methods are also explored in order to improve the signal quality and power efficiency. Finally, we are going to study about ACPR. ACPR is nothing but adjacent channel power ratio metric. Is introduced as an important measure of spectral regrowth and interference in wireless communication system, that is, such as LTE, 5G, and Wi-Fi. Overall, in this unit, it will cover the principles of feedback control, amplifier design, stability analysis, linearization method, and performance metrics, which are essential for modern RF and wireless communication system. Next, first topic is stability of feedback system. What is mean by stability? Yes, stability is the ability of a system to maintain a controlled operation and produce a bounded output for a bounded input. It produces a bounded output for bounded input. That is its stability. A stable system does not exhibit uncontrolled oscillations or diverge with time. Let us see the importance of stability. Okay? It ensures a reliable and predictable system performance, and it will prevent the excessive oscillation and system failure. That is a main important point in stability. It also maintains an accurate output in the presence of disturbance, and it is very essential for the communication, control, and electronic system. What is the role of feedback in stability? That will be the two feedback, right? Positive feedback and negative feedback. Negative feedback is that negative feedback feeds a portion of output back to the input in opposition to the input signal. We have already learned about it in control system, right? So that is a part of output signal will be feedback to the input. That is a negative feedback in opposition to the input signal. What are the advantages is that it will improve the system stability and it will reduce the distortion and noises. And it will also increases the bandwidth and it will make the performance, that is a system performance, less sensitive to the component variation. And it will enhances the accuracy and reliability. That is the main concept of negative feedback. For example, a real-time example is that a thermostat, that is thermostat controlled air conditioner, it will adjust the cooling. It will adjust the cooling based on room temperature and it will maintain a stable environment. That is a main concept. And in positive feedback, that is, for positive feedback, it feeds a portion of output back to the input. That is, in negative feedback is that it is opposition to the input signal. In positive feedback is that in phase of the input signal. That is, the feedback will be given from the output signal to the input in phase of the input signal. What are the advantages that it will increases the gain and it is used in oscillator circuit. That is a main advantage. And let us see the disadvantages. It will reduce the system stability. It may causes unwanted oscillation. That is a drawback. Let us see the example. That is audio feedback between microphone and speaker. That is a microphone and a speaker. The audio feedback will be given. That is, it produces a high-pitched squealing sound. And let us see the comparison of negative and positive feedback. That is a negative feedback, it increases stability, and in positive feedback, it reduces the stability. And in negative feedback, it reduces the gain, and in positive feedback, it increases the gain. These are the main points. That is the difference between negative and positive feedback. Okay. Let us see the conclusion. That is, stability is a fundamental requirement. Let us see the overview. What is meant by stability is that stability is a fundamental requirement in electronic and control system. That is, there will be the two types of feedback. That is a positive feedback and negative feedback. Positive feedback, that is the part of the output signal will be fed back to the input. In phase means it is a positive feedback. That is an opposite. That is out of phase is the negative feedback. That is negative feedback. It generally increases the stability and it will also improves the overall performance of the network. Why? In positive feedback, it will be carefully managed because it can lead to the oscillation and instability. That is the main concept. Okay, is it clear? Right? Let us see the key concept. That is, what is meant by loop gain? Yes, that is a product of forward gain path gain and feedback path gain. That is, G is a forward path gain and H is a feedback path gain. That is, it is a product of G and H is a loop gain. Okay. Loop gain generally determines how the feedback affects the overall system performance and stability. That is the concept. And in stability condition, that is a negative feedback system, the instability may occur. That is, GH will be equal to -1 at a particular frequency. Under this condition, the feedback signal becomes effectively positive. Okay. The oscillation can build up continuously. This makes the system maybe unstable. The importance of loop gain is that it will determine the system stability and it will affect the bandwidth and gain. It is mainly where it is used means it is used in amplification and control system design. The next is closed loop transfer function. Closed loop transfer function represents that is overall gain of a system after the feedback is happened. Is it clear? For example, that is input and output relationship. That is, it will causes a dynamic behavior of a system. Then stability. I've already told that positive feedback and negative feedback. Negative feedback is used to improve the stability, and positive feedback it's used to increase the gain and potentially leads to instability of the system. Next is gain. Gain and phase margin. Gain margin is the amount by which the system gain can be increased before the system becomes unstable. That is the definition. Simply, we can refer it as it indicates how far the system is from instability in terms of gain. It is measured at the phase crossover frequency. Phase crossover frequency is nothing but where the phase is, that is phase equal to minus 180 degree. Okay. Then interpretation is that if we have a large gain margin, is that the system is more stable. If it is have a very small gain margin, is that the system is less stable. Zero gain margin is that the system is on the verge of instability. That's a concept. And the phase margin is the phase margin is the additional phase lag required to make the system unstable. Simply, we can call it as it indicates how far the system is from the instability in terms of phase. That is, interpretation is that if you have a large phase margin, is that the system is better stability, and if it has a very small phase margin, is that oscillatory response. If it is have zero phase margin, is that the system is on the verge of instability. Okay, this is a concept here. Gain margin is the amount of gain that can be added to the system before it becomes unstable. It is generally we know that the unit of gain is decibel, right? So gain margin is also expressed in terms of decibel, that is a dB. The positive gain margin indicates stable system. Larger the gain margin, the greater the stability. And phase margin is that amount of additional phase lag that can be introduced before the system becomes unstable. Here, the phase margin will be represented in terms of degrees. Generally, gain will be represented in terms of decimal and phase will be represented in terms of degrees. The positive phase margin indicates a stable system. Larger phase margin generally results in better stability and less oscillatory behavior. Yeah. Let us see the importance of positive margin. Positive gain margin அப்படின்னா, that is, the system can tolerate the gain increases and remains stable. Positive phase margin அப்படின்னா, that is, the system can tolerate additional phase lag and remain stable. That is the main concept here. Okay. Then root locus technique. Root locus technique, that is, it is a graphical method. It is used in you have already learned it in control system measurement. Root locus is a graphical method that's used in a control system to show how the closed loop poles move in the complex plane. Usually, gain, that is, K is varied. The purpose is that it will determine the system stability and it will show how the effect of changing gain on